Okay, you can share screen now. Who's sharing? Siapa yang share screen sekarang?
Wait a minute, Doctor. There's a problem.
Syafiq.
I know. No
Okay,
need.
alright then. Okay, I'll wait. Siapa akan share? Who will share?
Alia will share screen.
Okay, Alia. Okay, yep, I can see your screen now. You can zoom in. Go to the show mode. Bottom right, ada slideshow, ada presentation mode. You can go bottom right. Yeah, cool. Yeah.
Okay. Assalamualaikum and good morning to Dr. Zamir and also our classmates. So today, our group is going to present solid state drive SSD. Right. Yeah. Right.
So is there a lag problem maybe? Now it's changing to the next slide. Okay, go ahead, continue.
Okay, who's presenting for today? The first presenter is me, Shafia, who's going to present the introduction of SSD. Then I'll continue this of factor, architecture and function, and also the form factor of SSD. Next, Akidah will explain how SSD works. We will continue with advantages of SSD. But not least, Ahadia will explain the differences SSD and HDD and also SSD manufacturers. Okay, next slide.
Shafia is it disconnected? Oh, okay, you're here. Okay, right then. Okay, continue.
Okay, before I go deeper in this presentation, let me give you an idea about our topic for today. Let's say when you want to store data on your computer, you have two reasonable options. You can go with old but cheap HDD or faster but more expensive called SSD. So today's presentation will focus on SSD and discuss differences between SSD and HDD. By the end of the presentation, know a bit more how SSD works. So what is SSD? SSD is similar to unified drive or a technology, without the processor being a permanent feature that replaces most of the hard disk drive. SSD is a solid-state storage device that uses integrated circuit assembly to store data persistently and function secondary storage in a hierarchy of computer storage that is used for storing personal data like pictures, video, music, and documents. In a computer, SSD also stores the operating system code, framework, and drivers that allow the system to boot up and operate. SSD do not have moving mechanical components which distinguish them from HDD. It is because SSD use flash memory to eliminate the moving part present in HDD and allow the computer to find the files faster. SSD is more resistant to physical shock. run silently, and have quicker access time. SSD stores data in semiconductor cells. As of 2019, cells can contain between 1 and 4 bits of data. SSD storage devices vary in their properties according to the number of bits stored in each cell. This topic will be explained further by Akida. So, next slide. So, SSD uses mainly two key component technologies. First, NAND flash memory chip and flash controller. These provide high read and write performance. SSD, like before. SSD based on NAND flash with fully leaked charge over time is less for period without power. This causes one out drive that exceeds their endurance rating to start losing data after a certain period of time. Therefore, SSD is not suitable for archival storage except for 3D point, which is a possible exception to this rule. SSD can use traditional HDD interfaces and form factor or newer interfaces and form factor. Interfaces and form factor will exploit specific advantages of flash memory in SSD. SSD also have limitation lifetime number of write and also slow down as they reach their full storage capacity. Okay, that's all from me. Then I will pass this back to next presenter.
Okay, hi, Assalamualaikum. Can you hear me? Hello? Boleh dengar tak?
Boleh Alia, boleh.
Okay, sorry. So for my part, I'm going to explain about architecture and function of SSD. So these are several components that are included inside the SSD, which is a controller, memory, cache or buffer, battery or supercapacitor, and host interface. The main component of SSD are controller and memory. Next. So first component is controller. It's actually an embedded processor and execute firmware level code, and one of the most important factor of SSD performance. The function also included backblock mapping, read and write caching, encryption, crypto shredding, error detection and correction, garbage collection, risk and read disturb management, and also well leveling. So for the next part is memory. There are several part of memory, which is flash memory based SSD, DRAM based SSD, and 3DX point. But mainly I will focus on flash memory based SSD and DRAM based SSD. Flash memory based SSD is basically used number non-disk flash memory. It also wait. Should I proceed or what? That's the no problem.
Tahu.
Stop.
Tak hilang makan. Ya.
Robi.
Ih. Postpone ke macam mana ni?
Hi, I'm so sorry. Suddenly disconnected. Can you hear me now? Sorry ya. Okay, tadi we were at page number 2, was it? Can you reshare screen? Share the screen again. Okay, we were at page number 2 now. Hold on. In this page. Can we restart from here? Okay, go back to the full screen and I'll press the record button again.
Start
Okay.
again with introduction, Doctor.
Okay, all right. You
Okay,
can continue from here.
So, SSD is much similar to USB flash drive or a thumb drive technology, but with upgraded storage solution with a promising feature that replacing most of the HDD. SSD is a solid-state storage device that uses integrated circuit assemblies to store data persistently and functioning as secondary storage in the hierarchy of computer storage. SSD do not have moving mechanical component which distinguish them from HDD. It is because SSD use flash memory to eliminate the moving part present in HDD and allowing the computer to find the files faster. SSD is more resistant to physical shock, run suddenly, and have quicker access time. SSD stores data in semiconductor cells. As for 2019, cells can contain between 1 and 4 bits of data. SSD storage devices vary in their properties according to the number of bits stored in each cell. This part will be explained further by Akida. So, Aliyah, next slide. SSD use mainly two key component technologies. First, NAND flash memory chip, and second is flash controller. This provides high read and write performance. SSD based on NAND flash will slowly leak charge over time if left for a long period without power. This causes worn-out drives that exceed their endurance rating to start losing data after a certain period of time. Therefore, SSD is not suitable for archival storage except for 3DX point, which is a possible exception to this rule. SSD can use traditional HDD interfaces and form factor or newer interfaces and form factor. Interfaces and form factor will exploit specific advantages of flash memory in SSD. SSD also have limitation lifetime number of writes and also slow down as they reach their full storage capacity. So that's all from me. Then I will pass this slide to next presenter.
Uh,
Okay, Sri will share, is it? Can you go to full screen down there, down top, sorry, bottom right. Yeah, go full screen, bottom right. Yeah, I couldn't see there. Okay, right. Okay.
Okay, Assalamualaikum and hi. Can you hear right?
Yes, yes.
My name is Nur Alia Nasrin. I'm going to present about the architecture and function of SSD. There are several components of SSD, which is a controller, memory, cache or buffer, battery or supercapacitor, and host interface. Next. So the key component of SSD are the controller. And first component that I'm going to explain here, every SSD include a controller that incorporate the electronic that bridge the non-D memory components to the host computer. The controller is an embedded processor that executes firmware level code and is one of the most important factors of SSD performance. Some of the functions performed by the controller include back block mapping, read and write caching, encryption, crypto shredding, error detection and correction, garbage collection, read scrubbing, and also well labeling. Next. So the next component is memory. There are several types of memory, which is flash memory, DRAM, and 3D point. But mainly, I will focus on flash memory and DRAM based SSD. Flash memory based SSD was manufactured used non-volatile non-D flash memory. What is meant by non-volatile is a type of component memory that can retain or store memory and information even after the power is removed. Besides, flash memory based SSD is lower cost compared with DRAM, and it also have ability to retain the data without a constant power supply and ensuring data persistence through sudden power outage. Flash memory SSD initially slower than DRAM solution, and some earlier design was even slower than hard disk drive. But this problem was resolved by controller that came out in 2009 and later. For SSD based on volatile memory, which is need constant power in order to retain the data, such as DRAM, characterized are characterized by very fast data access. Generally, it less than 10 microseconds. And it also used primarily to accelerate application that would otherwise be held back by the latency of flash SSD. And if power loss, the battery provide power while all information is copied from RAM, which is random access memory, to backup storage. And when the power is restored, the information is copied back to the RAM from the backup storage. And it's also needed internal battery or external AC adapter and backup storage system to ensure data persistence while no power is being supplied to the drive from external sources. Next. Cache or buffer. It is a type of flash-based SSD typically use a small amount of DRAM as a volatile cache, similar to the buffer in hard disk. And a directory of block placement and while labeling data is also kept in the cache while the drive is operating. Next. So for the next component is battery or supercapacitor. It's also another component in higher performing SSD and which are necessary to maintain data integrity, so the data in the cache can be flushed to the drive when power is lost. And some even hold power long enough to maintain data in the cache until the power is resumed. In the case of MLC flash memory, which is multi-level cell flash memory, a problem called lower page corruption can occur when MLC flash memory loses power while programming an upper page. So the result is that the data written previously and presumed safe and can be corrupted if the memory is not supported by the battery or supercapacitor. And this problem does not exist in SLC flash memory. Next, for the last component, host interface. The host interface is physically a connector with the signaling managed by the SSD controller. And this is the most often one of the interfaces found in HD. They include SATA, SAS, Serial Attached SCSI, PCI Express, USB, and Parallel ATA. Next. Okay, so for the configuration part, the size and shape of any device mostly depend on the component and size of shape of the component used to make the device. But traditional HDD and optical drive are designed around the rotating platter or optical disc along with the spindle motor inside. If SSD is made up of various integrated circuit and an interface connector, then the shape will not longer depend on the shape of the rotating media drive. For general computer, we usually use the 2.5-inch form factor, which is mostly found in laptop and the most popular. And for the desktop computer, we use 3.5-inch hard disk drive slot, a simple adapter plate, and can be used to make such a drive fit. Other type of form factor are more common in enterprise application. The SSD also can be completely integrated in the other circuitry of the device, as in the Apple MacBook, starting with the model 2010 model and 2014. SATA and M2 form factor also gain popularity, primarily we use in laptop. Next. There are several types of form factor of SSD. Firstly, standard HDD form factor. The benefit of HDD form factor would be to take advantage of the extensive infrastructure that are already in place to mount and connect the drive to the whole system. This traditional form factor are known by the size of the rotating media, which is commonly as 2.5-inch. Second form factor is standard card form factor. For application where space is premium and compact, like ultrabook or tablet computer, we will use a few compact form factor with standardized for SSD. For the third one, this on a module form factor is one type of a flash drive with either 40 or 44 pin parallel ATA, PATA, or SATA interface, and intended to be plugged directly into the motherboard and use a computer hard disk drive. Fourth one is ball grid array form factor. In the earlier 2000, a few companies introduced SSD in BGA or ball grid array form factor. There are many benefits, but the main one are they can lower power consumption and small chip package size to fit into the compact subsystem, and they can be soldered directly onto a system motherboard to reduce adverse effect from vibration and shock. The fifth one is box form factor. Many of the DRAM-based solutions use a box that is often designed to fit in a rack mount system. The number of DRAM components required to get sufficient capacity to store the data along with the backup power supplies require a lot of space rather than the traditional HD. So for the last form factor is bare board form factor. This is form factor that common to the memory module and now being used by SSD to take advantage of their flexibility in laying out of all the components. So for the next part, Akida will explain about SSD more.
So hi everyone, I am Nur Akida binti Mamadai. So now I'm going to continue on the operating principle of SSD. So before that, SSD is a solid state storage device that uses integrated circuit assemblies to store data persistently, typically using flash memory and functioning as secondary storage in the hierarchy of computer storage. So here's how it works. So solid state drives are called that specifically because they don't rely on moving parts or spinning disks. Instead, data is saved to a pool of NAND flash. NAND itself is made up of what are called floating gate transistors. So unlike the transistor designs uses in DRAM, which must be refreshed multiple times per second, NAND flash is designed to retain its charged state even when not powered up. And this makes NAND a type of non-volatile memory. So now I'm going to explain a bit about floating gate transistor. So a floating gate transistor is a complementary metal oxide semiconductor MOSFET technology capable of holding an electrical charge in a memory device that is used to store data. So MOSFET consists of two types, N-type terminal and one P-type terminal, and also a gate terminal. And the depletion region between the N and P-type sections prevent carbons from flowing between the two N-type regions, even in the presence of small potential differences between the drain and the source terminal. The gate contact is made of a highly conducting material separated from semiconductor by an insulator. By applying a suitable potential difference on the gate terminal, charge can be out from the source, and as a result, the barriers have prevented the flow of electrons and allowing electrons to flow from the source to the drain. And now the transistor behaves as a switch turned on when this voltage on the gate terminal is removed and the charge movement stops and hence turning the switch off. So this diagram shows a simple flash cell design. So electrons are stored in the floating gate, which then reads as a charge 0 or not charge 1. In NAND flash, a 0 means data is stored in a cell. It's the opposite of how we typically think of a 0 or 1. NAND flash is organized in a grid. The entire grid layout is referred to as a block, while the individual rows that make up the grid are called a page. Common page sizes are 2K, 4K, 8K, or 16K, with 128 to 256 pages per block, and block size typically varies between 256 kilobyte and 4 megabyte. So one advantage of this system is because of SSDs have no moving parts, so they can operate at speeds far above those of a typical HDD. So next slide. So this chart shows the access latency for typical storage mediums given in microseconds. So NAND is nowhere near as fast as main memory, but it's multiple orders of magnitude faster than a hard drive, while write latencies are significantly slower for NAND flash than read latencies, but they still outstrip the traditional spinning media. So there are two things to notice in the chart. First, note how adding more bits per cell of NAND has a significant impact on the memory's performance. It's worse for writes as opposed to read. So typical TLC latency is 4 times worse compared with SLC NAND for reads, but 6 times worse for writes. Erase latencies are also significantly impacted. the impact isn't proportional. Either TLC NAND is nearly twice as slow as NLC NAND, despite holding just 50% more data, 3 bits per cell instead of 2. So next slide. Next. So SSD users, there are 4 types of memories, but I only focus on 3 main types of memories, which is single level cell, multi-level cell, triple level cell. So SLC being the fastest and the most durable and are the most expensive form of SSD. MLC are slower in the write speed, and TLC can hold 3 bits of data in the cell. So next. So the reason TLC NAND is lower than MLC or SLC because it has to do with how data moves in and out of the NAND cell. With SLC NAND, the controller only needs to know if the bit is a 0 or 1. With MLC NAND, the cell may have 4 values, 0, 0, 0, 1, 1, 0, or 1, 1. And with TLC NAND, the cell can have 8 values. So reading the proper value out of the cell requires the memory controller to use a precise voltage to ascertain whether any particular cell is charged. So that's all for me. I'm going to pass on to another presenter.
Okay. I'm going to proceed with the types of a solid state drive. SSD can be classified in different form factors such as the type of connection. Some listed like SATA 3, PCIe, M.2 SD, and NVMe. Okay, first SATA 3. The connection works with the finite evolution of an older option, which works with both the solid state drive and the hard disk drive. This is a smaller driver and a bare circuit. These are used in a smaller capacity, usually found in notebooks, laptops. And then PCI Express. Okay, PCI Express or which is on Peripheral Connect Interconnect Express option connects directly to the motherboard of a direct flow of data, which in turn supports the SSD writing speed to around 1 gigabyte per second. As the interface, the SSD use the PCIe slot, which makes the of the PCI slot. Then M.2 SSD. Okay, these are similar M concept of having a bare circuit board. The difference compared to the other SSD is that within the M.2 form factor, there are a variety of different width and length combination, which brings in more flexibility in its stage. These types of SSD are typically used for mobile solutions such as notebooks or tablets. And then the last one is NVMe or non-volatile memory express. NVMe are the versatile PCIe connection which are easier to upgrade and generally faster. It is a commission interface which defines a command. Okay, next slide. The next slide is application solid state drive. Okay. Initially, solid state drive SSD designed for consumer devices. With the increased speed and power, various other sectors are also with a huge demand for them. Some are discussed below. Okay. For the first one, business sector. Companies are depending on programming environments or data analysis offered on SSD as access time and file transfer speeds critical. And then the second one is gaming. For every gaming program, the computer requires a third data access, enabling a faster load time which is provided by the SSD.
And then smartphones. With the continued developments in smartphones industry, the need for small size fast memory is best fulfilled by SSD. And then the next one is server. SSD can improve the server's response time due to its speed. Both for faster read and write operation. And the last one is smart wearable and gadgets. The latter space requirement, power consumption, and high speed makes it an integral part of smart wearable and gadgets. And then the next one is advantages solid state drive. The advantage of SD include first durability. It is being more large and heavy duty. SSD covers a very high number of drive cycles. The second one is speed. The speed accessed by the SD is 35 to 100 microseconds, which is 100 times the performance of HDD. SD can improve the online presence when it comes to hosting a website. This is with a faster website loading speed and efficient data storage. And then the advantages of SSD is availability in the market. SSD are available in various physical and memory sizes. And then the last one is low power consumption compared to the HDD. SSD consume less power since they don't have any moving part. Then disadvantage of solid state drive. The advantages of solid drive include first cost. SSD are more expensive than the HD, even after being a similar storage capacity. Then the data recovery. The data can be completely destroyed and can be recovered if of the memory flash is destroyed. And then the last one is storage. SSD face a major problem regarding the storage. The data can be written in empty blocks, however, when the block get filled, overwriting becomes an issue. Regarding the data is not affected by this. To avoid this issue, one has to transfer the data into another memory drive and raise the SSD to reload the data. I will pass to the last presenter from me.
Cannot hear you. Sorry. Okay, right. Okay, sorry, saya dah unmute you. Can you try? Okay, yes, I can hear you now.
Sorry, Doctor. Assalamualaikum. My name is Nur Ahadia binti Muhammad Jalani.
How come you? Okay, I thought sorry easier. I see on screen now.
I use
Reference.
Seri Iziani Webex account.
Okay then. Sorry. Yeah, then. Okay,
Doctor.
proceed.
Assalamualaikum. My name is Nur Ahadia binti Muhammad Jalani, and I'm going to present about the difference between SSD and HDD. In SSD, in SSD, all data is stored in integrated circuit. while in HDD, they use magnetic storage to store and retrieve data. There are significant speed difference between those two drives because HDD drive use spinning in order to perform read-write operation. So they are significantly slower than the SSD. For example, if you are moving file using SSD, the copying speed is generally from 200 megabyte to 550 megabytes per second, while in HDD, the speed of copying is generally from 50 megabytes per second to 120 megabytes per second. The rate latency time in SSD is lower than the HDD. In order to access the data, an HDD mechanical arm has to move to the right location on the storage platter to locate specific data, while SSD able to access data electronically, and that allow them to quickly access data. So HDD will need more time and greater latency to find the data. For file opening speed, the SSD can open 30% faster than HDD, and the random access time for the SSD is 0.1 millisecond, while the HDD can be 5 to 10 millisecond. As for the power consumption, SSD consume between 2 to 5 watts, while HDD consumes 6 to 15 watts. Because of having so many spinning objects inside. So it obviously requires more power compared to the SSD, which don't have any moving part, and it based on flash memory. So since the SSD does not demand much power, so it generates very little heat, as there are no moving part while the HDD produce more heat because it has moving part which is constantly moving around. Next one is the SSD is more durable than the HDD in extreme and harsh environment with longer lifespan, and the SSD has no moving part to fail mechanically, while the HDD have moving part and are subject to sudden failure. SSD have a failure rate of less 0.5%, while the HDD failure rate fluctuates between 2 to 5%. The storage capacity of SSD is very low as compared to HDD because SSD for computer are available in 120 gigabyte to 4 terabyte, while the HDD can go to 150 gigabyte to 14 terabyte. The last one is the SSD is more expensive than the HDD for the price per amount of storage. Next, I'm going to present about the companies that are related to the production of SSD. The first one is Micron Memory that based in Boise at the Idaho, and the location in the Malaysia is first is Taman Perindustrian Batu Kawan at Bandar Kasia, Penang. Second at the Pride Industrial Estate at Penang, and the last one is Tanjung Agas Industrial Area, Muar Johor. The second company is Intel Technology that based in California, and the location at the Malaysia is at the Bayan Lepas. I think that's all from us. Thank you. If there are any questions, please feel free to ask.
All right, guys. Thank you very much. So let's Q&A session on SSD. Anyone?
I have a question.
Okay. Siapa-siapa ni?
Amirul.
Okay, Amirul.
What is
Go ahead.
the material used to create a SSD drive?
Material used to fabricate SSD.
Yes.
Betul, Amirul?
Betul? What is the material to fabricate the SSD drive?
Okay. So proceed. Anyone would like to answer that? Okay. Material to fabricate SSD drive.
To fabricate SD, we are using silicon dioxide as our material. Is it a question?
Sorry, Filza. I couldn't hear you clearly just now. Sorry.
To fabricate SSD, we are using silicon dioxide in the MOSFET in the floating gate transistor in the floating gate MOSFET. We are using silicon dioxide.
It's silicon based.
Yes.
So is MOSFET the what I call? So the base device is MOSFET.
Yeah.
Okay, all right. Okay, the next question here from City. How long will SSD hold data without power?
Okay, I'm going to answer for that question. If SSD is lost without power, it typically to start release the data after about 1 or 2 years, depending on the temperature.
Okay, so if say at room temperature?
At 50 degrees, it can store around typically 1 year, and around
Okay.
25 degrees Celsius, it can store almost like 2 years.
Oh, it's so different, eh?
Yeah.
Between 5 degrees C.
Temperature.
So lower temperature is better for longer hours, longer duration.
From my reading, yes.
Oh, so if we are now in the UK, for example, then it should last longer. Betul, Alia?
I think it's by our manage. I mean, like where we put our laptop like that.
Okay.
If SSD is inside our laptop, then how we take care of it? Like we put it inside our room or inside the window that high temperature then.
Okay. All right, from Cornelia here, why SSD is more expensive than HDD? What makes it expensive?
I think that what makes SSD is more expensive than HDD because the fact that HDD used by production of magnetic disk. Production of magnetic disk is much cheaper than production of flash chips. That's why SSD is much expensive than HDD.
Exactly, it's in the fabrication process. So the equipments involved are more expensive for SSD than HDD. All right, next question here from Haziq. What is the difference between form factor of SSD and type of SSD? What's the difference between form factor and type of SSD?
Okay, I'm going to answer this question.
Okay.
For computer, it is more to shape, size, and dimension SSD. Then the type of SSD is I explain more about the interface that you use in the SSD.
Okay. Oh,
Okay,
all right. All right. Any other questions, guys? Any other question before my questions? 10:56 dah cepatnya. Okay, come on. Any one question?
In the company, right? In the company, what the research and development done by these two company in SSD and SSD development?
Okay. So any R&D activities going on in these two companies, Micron or Intel, for the future SSDs?
One that I know is Intel. The latest one that they developed is 3DX point SSD, which is the obtain SSD. That's it.
How big can that store, Filza? How many terabytes? Do you have any idea?
I forgot the bytes, but it's the one they use. They develop.
Okay. So what is the storage that we have for SSD now in the market? What's the maximum that we have seen before in the market now? We have a couple of terabytes already. Just now I saw up to 14 terabyte. Oh no, so that's for HDD, right? SSD is up to 4 terabyte, is it? Have you seen any 4 terabyte SSD dekat kedai komputer ke in the market? Have you seen 4?
Never seen that.
Oh, you pernah nampak 4 terabyte? Oh, pernah nampak? Oh, 3 terabyte. Hafizan have seen 3. How much is that, Hafizan? Do you know? 300 ringgit?
Tak pasti
3
lah.
terabyte. Berapa?
Tak pastilah. Rasanya
Tak
dalam
pasti
300 ke
300 kan?
kurang
Okay.
tak.
But well, do you need up to 3 terabyte anyway? Or now, or everything is on the cloud? Okay. Any other question? Okay, I have one question. Last question before we finish the class. Someone said just now we store by when you operate SSD, so it's 1 and 0s, right? 1s and 0s, and then we store the data during the zeros. I think was it Akidah? I couldn't remember which one of you. But so what do you mean by that? We store during and then we don't have any storage during 1, is it?
Yes, yes.
So that means when the MOSFET is off, the data is stored.
Yeah.
Okay. And when it's on, the data, well, is it related to any specific MOSFET that you've read before? Or
No.
any type of MOSFET does that?
I think it's for all the MOSFET
All
that
MOSFET.
yeah.
Okay, well, if you can find extra information, can you share in the group later on? Well, is it
Yes.
across all MOSFET, or because we haven't learned MOSFET, we're gonna learn after the presentation, and there are 2 types. They are enhancement mode and depletion mode, and we have P and N type. So we have P type enhancement depletion, we have N type enhancement depletion. So altogether we have 4 types. So what I would like to know is whether we do the storage of the data during the zeros of all MOSFETs, or is it specific to only enhancement mode or depletion mode, or maybe you can help to find some extra info and share in the group later on.
Yes, yes, doctor.
Okay then, so yeah, that's all. Thank you very much. Give it up to group number 6. Virtually. Okay, it's 11 already. So tomorrow we're gonna tomorrow is Friday already, right? So tomorrow is Friday, so we'll continue on next Monday with group number 7, and then Tuesday will be 8. I will let you know on Tuesday because about Tuesday, because Tuesday I'll be in a conference virtually. So if we are not able to do on Tuesday, we'll continue on Wednesday. Okay, but I'll let you know on Monday. So we'll continue with the next group then. Bye bye. Take care. Assalamualaikum. Thank you to this group.
Thank you, Doctor.
Thank you,
Bye.
Doctor.
Nanti the leader tolong send kat saya PDF ah. Thank you.